能看到吗？
嗯，可以，可以，你可以
好，
翻页，翻往下翻翻看。啊，好的，能看到，而且网
好，
络网络还可以。
好的，
好的，我们这边也有备份啊，万一有什么问题，我们这边也可以放。
哦，好的，好，
嗯，好。然后
嗯
等一下，今天学员到的比较晚，现在13个人，我估计我们待会儿可能3:05开始等学员上线。
嗯，好，
嗯，对。然后刚开始我会先开个场，然后介绍一下您，然后再请您开始。
好的，好的，没问题，
嗯，
嗯，
好，好，那您
好，
先
那就这样，
休息一下啊。
好，
嗯
好，好，嗯
嗯。
嗯。
Okay, I think we can get started. Dear participants, ladies and gentlemen, welcome back to today's training course. Today we'll have a lecture on the development and application of dam safety monitoring technology in China, given by Professor Li Hong'en. First of all, let me give a brief introduction about Professor Li Hong'en. Professor Li is in charge of more than 20 national research projects, including Chinese National Key R&D project of National Natural Science Foundation of China, key research projects of Ministry of Water Resources of China, etc. As the main writer, he participated in the development of water science and technology development strategy, the National Key Research and Development Plan, and the 13th Five-Year Plan for the development of water conservancy science and technology. As the Ministry of Water Resource Reservoir verification expert, he completed the verification of more than 30 reservoirs with defects through systematically carrying out research work on reservoir dams and dam breakage mechanisms, safety diagnosis, monitoring and early warning, risk assessment, and risk management. He completed more than 30 research projects, published 5 monographs, and participated in the compilation of 2 regulations, and publicly published more than 20 academic papers. He owns 2 national invention patents and 6 software copyrights. Now, ladies and gentlemen, let's welcome Professor Li Hong'en to give us a lecture.
Okay, thanks, Ms. Xu. Dear all, let me share the screen. Okay, it's my honor to make this lecture. The topic is development and application of dam safety monitoring technology in China. I'm from Nanjing Hydraulic Research Institute. Also, right now I'm working in Dam Safety Management Center of Ministry of Water Resources. So this lecture will be divided into 4 parts. In the first section, I'll make a brief introduction of the purpose of dam safety monitoring. The second section will show you some basic technologies of dam safety monitoring. The third part will show you some cases of dam safety monitoring technologies. And in the final part, some recent developments, achievements in this area will be discussed. So let's move on to the first part, the purpose of dam safety monitoring. We all know dams or reservoirs are very important for every country, for people, for economics. But when the dam failure happens, it may lead to serious consequences. So in the first part, I'll show you some dam failure cases happened in recent years. So this slide shows you some functions of reservoirs in China or also worldwide. The reservoirs play very important roles in the area of flood control, irrigation, water supply, ecology, so forth. But sometimes when dam failure happens, the consequences are serious. From the year 2018 to up to today, several dam safety consequences, accidents happened, and the emergency response is difficult under the background of this pandemic. Extreme weather, climate change, floods, and rainstorm are the induced reasons. And the problem of reservoir aging problem exists objectively, also related to some other reasons, such as construction, quality, operation management error, and human error factors. The first one I want to show you is, sorry, there is. I want to show you this case. This case happened in Hawaii island on Pacific. This dam name is Kampakailua, caused by overtopping at March the 8th, 2021. According to the local news, local media, 2 people were lost by the flood that day. One of them was rescued. The characters of this failure case is that the dam is very old. It was built in 1885, and the height is 17.4 and 122 meters long. The residents downstream of the dam have been warned to evacuate. So according to the data from the local media, the rainfall from 7 a.m. to 15 p.m. that day reached, it's a very large value, reached to 335 millimeters, really very heavy rain level. So we check some background information based on the data released by the U.S. Army Corps of Engineers. There are 133 dams in Hawaii with an average age of 88 years, of which 98% are state management dams and 2% are federal dams. So in the United States, most of dams are the owners are private owned. According to the 2019 report by the American Society of Civil Engineers, 93% dams in Hawaii are classified as high risk, meaning that failure could result in significant loss of life or property. And early in 2006, also another dam, Kaloko Dam, collapsed in Hawaii, caused casualties. 7 people died due to the dam failure. So we can see dam failure may cause people die and cause a lot of influence to the local area. Another case happened, in India. This dam failure caused by the rupture of the Nanda Devi Glacier in the Indian Himalaya led to a dam failure on February the 7th, 2021. And more than 150 people died or disappeared during this accident. Clearly, this dam failure case caused by the climate change problem. So we check some background information. We know this is a neighborhood of China, Himalaya area, and this area, flooding and landslide are prone to occur. In 2013, devastating floods occurred and led to more than 6,000 casualties. It's very terrible. And another case, this happened in Uzbekistan in 2020, May the 1st. This dam, this reservoir's name is Sardoba. Maybe you hear this accident. The dam is about 29 meters high and has a storage capacity of 920 million cubic meter. It's a very large reservoir. Based on the Chinese standards, it is a large 2 level, large 2 type reservoir. Construction was completed in 2017. You see, it's a really young dam, very new. It's completed the construction in 2017. 3 years later, it collapsed. And the function of the dam are irrigation and power generation. Clearly, this dam, the main function is to store as much water as possible. So on the day of May the 1st, this day, this area encountered heavy rainfall and the water level rose rapidly. And the dam on the west side suddenly burst, and the flood rushed to the neighbor country, another neighbor country. And this dam failure related to the factors such as the project quality, anti-seepage defects. It believed that the failure of the dam caused by the seepage problem directly related to the construction quality, and also the excess storage during flood season and the improper construction are other factors to lead this dam failure. And this dam failure caused 4 casualties and more than 75,000 people evacuated. This slide shows you some pictures, pictures from the dam failure site. You see the president arrived the field, the area rapidly. So you know this dam failure is very serious. Then I'll show you a short video to illustrate what happened when the seepage problem caused the dam failure.
One degree or another. While the dam experiencing seepage may appear in sound condition, there may be damage occurring to the internal structure of the dam. If seepage flow rates appear to be increasing and the flow is not clear and is carrying material, internal erosion or piping is likely occurring. Piping is an erosion process that occurs inside the dam whenever the seepage flow starts eroding embankment materials out of and away from the dam. This starts at the downstream slope or toe and moves rapidly upstream to the impoundment. This process will tend to accelerate as the expanding larger opening or pipe allows for increased seepage flows. If left unattended, the seepage flow and progressive internal erosion will soon get out of control. When the internal pipe or void becomes large enough, the embankment structure above it will collapse. This will result in a failure of the dam's embankment and a potentially catastrophic release of the stored water, which may cause serious property damage and loss of life.
Okay, this video show you the main process of dam failure caused by seepage problem. So in the later part, we'll discuss some monitoring technologies to how to the monitoring the seepage. Next case is Edenware and Sanford Dam failure in Michigan, United States in 2020. And these 2 dams are also very old, built in 1924 on the mainstream of the Tabawasi River. They are made for power generation and tourism. So, and that day, local time in the United States, due to continuous rainfall, the Edenware Dam in Michigan first collapsed, and then the floodwater washed away. downstream to the next dam, the Danforth Dam, forcing about more than 10,000 people in the central Michigan to evacuate. So the continuous rainfall, aging engineer, and insufficient maintenance are the reasons for the failure, and the lack of discharge capacity of Edenware Dam is the main cause. So this slide show you the process of Edenware Reservoir dam failure process. Let's see the video. Clearly, this dam case failure case more or less same to the former one, to the former video showed to us, but we'll then check a lot of information from the internet. We found some not very good background, because the main reason why Edenware dam failure happens is insufficient capacity of spillway. So we check the files released by the local government. In 2018, the owner of the dam, the Boise Hydro, was suspended by the FERC and banned from generating electricity after the Edenware Dam was assessed as a high-risk dam due to its long-standing failure to solve the problem that we have mentioned, the inadequate spillway discharge capacity problem. So the government asked the owner to realize the reservoir to meet the requirement that the capacity of discharge should require to the PMF possible maximum flood, but the actual discharge capacity only 50% of this requirement. Interesting information is that when this problem was found, it's 1999, almost 20 years ago. However, nobody pay enough money or to make enough to pay enough assessment to fix this problem, and finally the dam collapsed. So for every owner of the reservoir should pay attention to the maintenance of dams or reservoirs. And then but in this case, we have some lessons learned because of the better emergency response system in this area, rainfall forecast, and dam failure warning. Nobody died. No casualties happened in this dam failure. So we know a good monitoring system and warning system is very important for dam safety management. And then another case, is this one, is Tom Brook Reservoir spillway accident in United Kingdom happened in 2019. And this is also a very old dam. its age is more than 180 years old, and this dam is approximately 24 meters high. Also, heavy rainfall happened, and the water level rose sharply by 100 to 300 millimeter. And on August the 1st, 2019, the auxiliary spillway of this dam was severely damaged due to heavy rain. But thanks to the emergency accident, so the dam owner carried out several measures to lower the emergency. One is to use an emergency pumping operation. It effectively alleviates the impact of heavy rainfall on the dam. And the army, the British Air Force helicopter dropped each 1-ton sandbank and the spillway site, dropping a total of 530 tons of sand, and the ground personnel solidified these sand banks with concrete. Some factors lead to this accident. One is the design problem. You know, it's a very old dam, so the spillway is poorly designed and not strong enough to discharge the maximum possible flood. And another reason is management issues, like poor supervision, failure to reinforce in a timely manner, and some other maintenance work errors. Another case is also a very famous dam incident. It's Oliver dam incident, spillway problem, happened in 2017. This dam is very important for the local area. It's the tallest dam in the United States, and it's very important for the local water supply. And due to the rain and the snow, the water level raised rapidly, and then the owner used the spillway first, but some huge collapse area appeared in the spillway. The owner have to use the emergency spillway, so caused a lot of problem. But the main reason of this dam incident I show you here is some other problems. We see this spillway problem was found several years before this accident, but nobody paid enough attention, and the local engineer not play a they just to observe from far and not approaching to the dam site. Also make the conclusion like looks okay. It's not a professional decision of this kind of dam. So it's a horrible thing. And then we move on to another video. We'll show you what happened when overtopping happens. How the process continued.
Dams are designed to store runoff resulting from heavy rain. When storage has reached a specific limit, spillways are designed to pass the excess floodwaters, initially through a primary spillway. Many dams are equipped with an emergency spillway to help pass large flood inflows which exceed the capacity of the primary spillway. In an extreme flood, flows can exceed the combined spillway capacity, spill over the top of the dam, and create a very dangerous situation. Overtopping flood flows can rapidly erode down into an earthen embankment dam, leading to an uncontrolled release of the stored waters and causing catastrophic flooding downstream.
Okay. The last one, I want to show you the dam failure case is the Xiepai dam failure happens last 2018, and this dam missed and 9 people died. This dam failure happened on July the 25th, 2018, and the dam collapsed, and 13 administrative villages were directly influenced or have to be transferred to safe place to evacuate. And we check some information from this dam failure because the design, the owner of this dam is a Korean company. It's PNPC. On the day 23rd July 2018, they make an announcement to the downstream that over 5,000 million tons of water would be flow out to downstream of this river. This day is 2 days before the disaster happened, but the local government didn't pay enough attention to this announcement, and no people were transferred to safe area. So after the dam failure happened, a lot of people died. So this dam failure case tells us the warning of dam safety is very important to the public. After this dam failure happens, the ICOT, the International Commission on Large Dams, rapidly released one release to the public. They told us dams are critical pieces of not only physical but also social economic infrastructure that supplied different functions. So like other large infrastructure in our societies, dams provide critical service, but also pose high risks that must be addressed during the planning, design, and the construction phases. The precautionary principle of dams to prevent and mitigate adverse downstream safety consequences informs and is the heart of this commission mission, and also for the owners of dams, for local government mission. So we have discussed a lot of dam failure cases. Then we make a short summary that what are the main dam safety problems. Normally, when I want to take the Rockfield Dam, for example. For this kind of dam, the first dam safety problem is the flood prevention problem. We know most of us to build a reservoir to realize the flood control function. So like Edenware Dam, like other dam failure problem, this problem have several characters. One is because of insufficient rainfall or flood or river data, unreasonable design of flood standard sometimes happens. Second, encountered over standard flood due to rainstorms, due to climate change. And then some rivers may face the sedimentation problems. And this problem may lead to severe reduction in flood storage capacity. The second problem is seepage problem. Seepage problem is another very important reason. This problem may happen in dam body or the foundation, and also may happen on the interface between dam body, foundation, and the concrete structures like conduit, like spillway, and some seepage problem happen on the abutment. And then the third problem is structure problems. This kind of problem can be summarized like dam crack, partial collapse, dam body slide, abutment instability, dam foundation liquefaction due to induced by earthquake, and termites and other animal hazards. This is also very important problem to rockfill dams. Okay. Until now, we have discussed a lot of dam failure problem and dam problems. So how to monitor dam safety status by proper methods? Here, in this part, we'll discuss a lot about in this section. So the purpose of dam safety monitoring can be summarized as during construction period, operation period, and for scientific research. So first, during construction period, monitoring data can be used to check the reliability of design and the quality of construction, and hence revise the design or change of construction scheme if necessary. This slide shows you some dam site under construction. During operation period, the first-hand monitoring data can be used to analyze the safety status of dams and their potential risks. Measures can then be employed to ensure the long-term safety of dams if necessary. So dam safety monitoring technologies are very important during the operation period, especially for very large, important reservoirs. And finally, for scientific research purpose, dam monitoring data provide the most valuable and reliable basis for the verification and the improvement of theories in dam engineering. Imagine a real project like a 1:1 scale experiments, right? It's very important. Its data is very important for the development of dam design and construction technologies. So in China, rigorous requirements in dam safety monitoring by Chinese government. We have different kind of technical specifications for different type of dams, especially for rockfill dam, for concrete dam, and also for the monitoring system, how to realize this kind of system. So we have finished the first section, the purpose of dam safety monitoring, and then let's discuss a little bit about technologies of dam safety monitoring. First, I want to show you the characteristics of the dam monitoring. We know dams in dam safety monitoring include dams, its foundation, abutment, and near dam slopes. And they all have a major impact on dam safety and other buildings and equipment that are directly related to dam safety. All these objects should be monitored. Its characteristics are expressed in the following aspects. It's a life cycle problem. We mean during the construction period, the operation period, and also when the retirement period, we also need dam safety monitoring. It's a dynamic and not static process. It's also a relevance items. It's covered very great range. That means not only dam itself, but also the facilities, structures related to the dam. It's very complex. And also to realize the monitoring, we should plant a lot of sensors on the dam. So the construction normally is very difficult, and their operating environment normally are very poor. It's a semi-theory and a semi-empirical design, construction and operation management. So show you the load diagram of one certain gravity dam. We know there are different kind of loads, and on these loads, the dam should have some response with pressure, with seepage, and like this uplift pressure and sediment pressure. When seismic or when earthquake happened, this have inner tier response. All this response we should to monitor. But for different dams have different requirements. We'll discuss it later. And this slide show you the deformation caused by water load. It may be slide or maybe rotation. Different kind of this deformation can be monitored by proper technologies. So several common concepts like detection. Detection normally means short term. Monitoring means long term. Observation means surface artificial methods. And monitoring and controlling means we monitoring the data, realize the analysis, and then feedback to the decision. And the healthy monitoring means for structure and damage diagnosis, detection, risk analysis for structure, for the probability of the failure, and also the consequences of the failure. We amplify these two factors and to realize the risk analysis. And also another concept is the safety assessment. This means we should to evaluate the safety status of one dam. And back analysis means we use monitoring data to carry out the back analysis and to fix, to calibrate the material parameters. And we use this parameter to make another analysis and then to evaluate the safety status. It's a little bit a complicated process. And finally, right now we discuss the technologies of dam safety monitoring. So since last century, 1960s, significant progress have been made in dam safety monitoring area. from systems and methods and sensors, so such as monitoring instruments and data processing and analysis methods, development of dam monitoring systems, application of computer and software technologies, and dam safety evaluation. So they can be summarized in the following aspects. So the next slide show you these 4 aspects. The first one about sensors, different kind of monitoring instruments. And when we, after finish the placement of instruments on dam body, we have to gather the data. So the second one is data acquisition system. And then we have a lot of dramatic amount of data. We have realized the analysis of the data. So we need information management system. And finally, we should have mathematical methods, like different kind of data analysis methods. So these 4 parts are the very basic aspects of dam safety monitoring technologies. Okay. So the first part is monitoring instruments. Normally, when we talk about monitoring items, we have different aspects. The first one is manual inspection, and manual inspection, and then for is deformation, seepage, stress strain, and temperature, environmental quantity, and others. The first one, the manual inspections also need instruments, use very simple instruments, such like rulers and other instruments. But this is very important, especially during the emergency period of flood season. Manual inspection, very, very important. And here, I'll show you some tables of different kind of monitoring groups and monitoring items. And for different, for large dam, for medium-sized dam, and for small dams, the requirements are different. So we see for inspection, we have regular, annual, and special inspection. For deformation, we have superficial deformation, internal deformation, crack, interface, and slope deformation, and concrete slump. And for seepage, we have seepage quantity and seepage in foundation, in dam body, and in abutment. And for pressure and stress, we have pore pressure, earth pressure, contact pressure, and concrete for concrete slump. And for hydrology and meteorology, reservoir level very important. Precipitation, rainstorm, rainfall very important. The others like water temperature, reservoir wave, less use. But sediment are very important. Ice very important. For some dams, a reservoir located in the north part of the earth. Earthquake also very important. So for manual inspection, we have some requirement. So for personal requirement, the engineer to carry out the manual inspection should have be trained properly. They should have enough sufficient experience. Relatively fixed people, you cannot change different people to do this. And should monitoring data requirements should record properly and contrast different time results. And the route requirement, there are successive and reasonable routes to do this. And the time requirement, we should plan and consistent. And the last one is requirement for results processing and inspection. Okay, and then these slides show you some typical monitoring instruments. So we see to realize deformation monitoring, we have total station, clinometer, settlement gauge, plumb line. Also, we have other instruments. This just for an example. And for seepage monitoring, we have this water level gauge, pressure meter, measuring wear, and the tube tilt meter. And for strain and pressure monitoring, we have river meter, strain meter, strain gauge group, and earth pressure meters. And for the environmental monitoring, we have different kind of meters for wind, for rainfall, and for water velocity meter, for water velocity. So let's discuss a little bit in detail on the environmental monitoring. For water level, the manual reading can be done with the water level gauge, or different types of water level gauge can be used for automatic measurements. And the temperature meter is mainly used for manual or automatic monitoring. And rainfall monitoring using a rain gauge meter. And others like sedimentation, breathing, wind speed, air pressure, and evaporation and other items can be monitored using appropriate instruments. And for deformation measurement methods, so for surface deformation, we have sightline, triangulation, precision level, extension line, vertical line, laser alignment, total station, GPS or GNSS, implement different kind of technologies. And for internal deformation, we also have this kind of meters. So the extension line horizontal displacement meter and water pipe settlement meter are mainly applied to very high face rockfill dams, or concrete face rockfill dams. And for seepage management method, first for leakage, we have volumetric method, and it's normally realized by different type of equipment. And upper lift pressure, we can use water level monitoring instrument installed in the pressure measuring tube can realize automatic monitoring. And seepage pressure, mainly through the monitoring of buried osmometer and piezometric tubes, the choice of which mainly depend on the rate of change of height, permeability coefficient, and distribution and other factors. And seepage around the dams, the main use of pressure measurement method to monitor the stability of the dam slope. And then for stress, strain, and temperature measurement method, we normally use also use different strain or stress gauge to realize concrete stress, steel stress, and earth pressure monitoring. Normally during construction period, this are very important. Especially, we should know the temperature monitoring is very important for concrete dams. We know proper controlling measurements should be made to lower the crack happen probability in concrete dams. This is very important. And others many discuss on earthquake and hydraulics. We know earthquake it's a very it's a suddenly load on dam body. So we should know the response of the dam. This is very important. We have proper sensors. And hydraulics means we should know the flow state of, especially on spillway. Just now we discussed the Oliver incidents. We should know the flow rate and the surface line and erosion, vibration. This also can be monitored by proper methods and instruments. Okay, and the second part is data acquisition system. So this is also very important. The development trend of data acquisition system right now are from manual to automation. Clearly, most of them right now are automatically to realize the data acquisition, and from centralized to distributed, from distributed to intelligent model networked, and also compatibility and reliability are very important for this kind of system. Diversification of communication network and the power supply, and the resource sharing and data mining also very important. This slide show you one of data acquisition system. Clearly, this for very large dam, small dams or small reservoirs is much simple. And also need a lot of hardware of automatic dam safety monitoring system. Especially we need the measurement controlling unit and the system communication. We can realize the communication by wireless method, or by wire, by fiber, or by cable to realize the communication. In the third one is the information management system. In this system, right now we have data from the dam body, and we should to realize a lot of tables and time curve. We should use this kind of system. I'll show you some diagram. This is one diagram of this kind of system, and also and then we also use a data analysis method. Clearly, most of them we need some background of mathematics. So the general interpolation statistical theory and mathematical morphology need to realize the error analysis first, and then we have to use the data modeling. So we need general probability and statistical models and deterministic and mixed models and GM models, and also others. Right now, the BP model very popular, and neural network very popular for data analysis. Finally, sometimes we use a different kind of series, so that means combination models. Based on these models, we should know physical laws, yield criteria, monitoring indicators. Also, the trend analysis, correlation analysis, and component analysis are very important for dam safety monitoring. So this slide show you a time curve of precipitation, rainfall, and temperature. Based this environmental monitoring data, we coupling with water level, we can analysis the relation between precipitation and the water level, and also water level, displacement upstream and displacement downstream. Based on this time curve, we'll know the deformation process of the dam. Also, this slide show you the same purpose of correlation between displacement of the dam and the temperature of the environment. Also, based on this system, we can realize the contours, a lot of like groundwater level contours, and the groundwater level magnitude can be drawn in this system. Also, sediment distributions and sediment contours can be drawn automatically. So we have discussed a lot of monitoring technologies, and the last part we discussed a little bit extra method like geophysical detecting methods for dam safety and reservoir management. We know, I think other experts may show you this slide. Right now, almost 100,000 reservoirs in China, and most of them are old dams. Some of them are with low construction standards and poor engineering quality. So risk and security problems are prominent, and flood control security is very important for us Chinese reservoir owners. So just now I discussed the main different kind of problem with dams. Most of them very important one for rockfill dam is seepage problem. Like this slide show you the dam foundation leakage, contact leakage, and the conduit leakage. So typical protection safety hazards of seepage in earth dam, just now we have discussed a little bit, and how to detect them, by detection method. I'll show you this slide. The left part, we have discussed the safety monitoring instrument, but also we have some detect methods like seismic, temperature, and sound electrical method to detect. And clearly, the acting inspection is directly way. It's very direct. We have dry ground detection method. We have high accuracy, but this kind of method have a clear disadvantage is that is high cost of high impact and time consuming, and laborers and the partial reservoirs are not allowed to empty. Some of them, especially for water supply. And then we have diver inspection. It also have high precision, flexibility, and a wide application range. But the disadvantages is that diving depth is less than 60 meters. And with high labor intensity, limited working time, and a certain risk. And so recent technologies, right now we have different kind of machines, like this is underwater television. Clearly, it's much flexible and easy to operate. But disadvantages are only structure surface defects can be checked, not the leakage velocity. Okay, and then we have isotope tracer. This kind track the leakage point and the leakage passage accurately. And environmental pollution, drilling damage of dam structure are disadvantages. And the flowing field method, its advantages is high resolution, strong anti-interface ability, but its disadvantages is it is only suitable for dikes or homogeneous earth dams and has fewer success cases for composite dams. And last is electromagnetic method. There are a lot of methods in this area. It's low cost, high resolution, and high efficiency, easy operation. But the disadvantages are large signal intensity attenuation, limited measurement depth. So new breakthrough in leakage detection technologies are urgently needed. And we have discussed two sections, and the last two sections are cases and advancement. Okay, shall we have a little break? 10 minutes later, we'll begin the second part, okay?
Okay.
Okay, shall we begin the second part of this lecture? In the next section, we'll discuss some cases of dam safety monitoring. So let's move on. So the first case are some milestone projects. The first one, I believe you should know this project is Three Gorges project on Yangtze River. I think this is one of the most famous hydraulic hydraulic project in China. It's a very large reservoir. Today I finished this slide. I want to show you the whole process of how we construct this dam. In last century, 1993, the preparation for construction began, and 1994, the December 1994, the first stage construction began, and in the year 1997, November the 9th, the Yangtze River cut off. So it's the beginning of the second stage of construction. And then 2002 October, the evaluation of the left part of the dam reached to 185 meters high. And then several important time node. And in the year of 2006, the evaluation of all part of dam reached to 185, and the impounding water level up to 156, and the initial operation period began. And then 2008, 26 hydro generators turned to normal operation, and 12 impounding to 175 meters. And then the year of 2015, the project successfully passed the checkup for acceptance of a completed project. And this project earned a lot of awards. This slide show you this project itself. The Three Gorges project won the FIDIC Centenary Awards of the year 2013, and it's part of the project. The lift of this project won the FIDIC Merit Awards 2019. This picture I photoed several years ago from the upstream of the reservoir, and this is another side of view of this dam. I want to show you the case is a part of the monitoring system. That is ship log, the Three Gorges permanent ship log monitoring system. What we have done, we see the permanent log internal diagram. These some pictures. It have file level, file section of this whole ship log. So we plant a lot of measurement controlling unit to collect the data from lots of sensors, and also we see this picture show you the MCU installed in the permanent ship log of the project. And these cables connect a lot of sensors, such as deformation, seepage, and other kind of stress, temperature, different kind of sensors. The second case is Gezhouba Erjiang sluice gate. This it believed that it's China's first distributed dam safety automatic monitoring system. Clearly, it's old. It's like 1990s, we plant this system on this dam. And another one is the Chencun Dam. It's also this case. It's a little bit old, 1990s. Here, I show you the measuring point evaluation layout of the dam. We see lots of sensors are planted on the dam body. It's a concrete gravity dam, so lots of crank sensor and stress and temperature sensors are planted. Are used. You see, it's it's arch dam, arch gravity dam. This is a bird wheel of the dam. And also, this slide show you the Chencun Dam monitoring system, the whole system diagram. And after some milestone projects, we pay more attention on some recent cases. The first one is right now it's the highest concrete face rockfill dam. It's Shibuya, a concrete face rockfill dam. Its height is 233 meters. We also this kind of dam we should know the real deformation during the construction period, also the impounding period. This are very important. We should know the artificial deformation, also the superficial deformation and the internal deformation. So this slide show you the section of this dam. The sediment and horizontal displacement gauges were installed at 5 different elevations. Each blank dots means one sensor, one displacement gauge. So we plant lots of this kind of gauges to monitor the internal displacement. So this slide show you the monitoring data. The settlements of different points during construction, impounding, and operation period were obtained. We see here the first part of this curve construction period and the impounding period, and then horizontally part means its operation period. And the deformation distribution within different zones were obtained, providing very important basis for the understanding of the working performance of the dam. So this slide show you the deformation distribution with different zones of this dam. And the steel ribber meters and strain guards were installed and different evaluation upon the concrete slabs. We know the cracks of the face should be controlled to guarantee the seepage, the anti-seepage system. So we should monitoring the deformation of the concrete face. Here, the recorded stresses of rebar can be used to analyze the effects of construction, water load, and the temperature on the slab stresses. And the compression and the tension of the vertical joints between slabs were obtained to analyze the working condition of the concrete slabs. And here, this slide show you 3-dimensional displacements of peripheral joints. The second recent case it's the highest construct Earth's core rockfill dam. Its height is it's Nuojiadu rockfill dam. Its height is 261.5 meters high. But in fact, right now, another very high dam is under construction. Is Shuangjiangkou rockfill dam on the Daduhe River. Its height is 314 meters high. It's still under construction, but this one had been constructed. The Nuojiadu rockfill dam. Here, I show you the displacement monitoring points for rockfill shale. It's this type of the type of this dam is a little bit clearly it's different to the Shibuya dam. It's we each have a vertical wall, a vertical central wall to anti-seepage, to it's an anti-seepage system. So this this core wall is very, very important. So the stress monitoring points, we plant a lot of sensors, especially incliminal meters were implanted in the central of this core. And also the superficial deformation were measured by collimating lines. We see this slide show you different the monitoring results of horizontal displacement and settlement. And the observations made on 3 monitoring sections reveal the settlement distribution of Earth's core and enable us to analyze the working condition of the core. This slide shows you the settlement history of typical points and settlement distribution of downstream rockfill. And also we can guide the pore pressure data. We know for this kind of dam, the arch effect of the core wall sometimes happen. So from this picture, this result, we can see the arch effect is not very obvious in this dam. So this means the engineer construction of this dam is successful. So this is the Earth pressure distribution with the core wall. Also means you see there is not a very obvious arch effect. So this means the construction, the controlling of the engineering compaction measurements are successful. Another one is a dam, a reservoir, which is subject to a very heavy earthquake. This is the only concrete face rockfill dam experienced a very strong earthquake and has detailed monitoring data. It's Pingpu rockfill dam in China, in Sichuan province. And what happened to this dam? In 2008, a very heavy earthquake happened. And the central of the earthquake is very close to this dam. So this slide shows you some pictures, photos from the dam site immediately after the earthquake happened. So you see the longitude crank and the compressive failure of slabs some transversal crack near the abutment and shear failure of horizontal construction joints. So this kind of problems and this kind of damages happen on the dam. The dam stand there, and dam failure didn't happen. So this means the quality of this dam is very good. So this slide show you some horizontal displacement and settlement displacement, and the crest after the dam, the crest moved towards the center of the canyon, and the crest moved towards downstream. And this is the general movements of the dam. And for the settlement, the crest settled considerably within a maximum of 74.4 centimeter, accounting for 0.64% of the dam height. It's a reasonable results. That means the compaction of the dam body during the construction period is good. And the settlement and horizontal displacement guards were installed at 4 different elevations. So what happened? What we got? This slide show you the earthquake-induced settlement of different monitoring points were obtained successfully. You see here, in this rectangular, you see the sharp increasement of displacement during the earthquake. And the settlement distribution within the dam after the earthquake and the horizontal displacement within the dam after the earthquake are showed on this slide. And the monitoring data show that the dam exhibits an overall contraction behavior during the earthquake. It's clearly obey the normal way of a Rockville Dam after earthquake. So we discussed a lot of cases of dam safety monitoring and some cases of dam failure problems. We up to now we know dam safety monitoring very important. We can get a lot of useful information from dams by this kind of technologies. So what are the recent advancements in this area? So in the last section, we'll discuss a little bit on this topic. So some new technologies. The first one I want to discuss with you is the fiber monitoring technology. This distributed optical fiber monitoring typically used on dams on civil engineering area. It's very, I think it's very convenient and very useful. And you can, comparing to the traditional ways, this kind of technology can realize continuous measurements of the deformation and the temperature, especially for rockfill dams and for earth dams, and also for embankment. This technology is very convenient. And others detectors like this ground penetrating radar, it's have very high precision, a wide range of flexible application. But it's the detection depth is limited. For this method, normally its limited depth is around 20 meters to 30 meters. For small dams, it's okay, but for large dams, it cannot detect sufficient enough for the detection scale. And for large dams, another facility is very important. It's the robot with inclinometer. For some very high ratio dam, right now in China, we plan this method. We plan this sensor, this system on inside the dam body, and the robot deformation monitoring technology can be tapped to ultra high dam, and the pipe length can be reached to 1,000 meters, and complex environment, high degree of automation. It's good, but it's a little bit expensive. And this one is kind of just now we mentioned the GNSS, the Global Navigation Satellite System. That means we can realize the deformation monitoring automatically by satellite. We know right now different countries, different continents have their satellite system. Right now in China we have Beidou system, and for United States they have GPS. For Europe they have Galileo, and for Russia, GLONASS. And right now we have private company have their private satellites, but this I think is a trend for dam safety measurement, also for deformation monitoring. It's very convenient, and the cost of this kind of technology right now reach to the level of acceptable. In old days, it's very expensive, but right now it's become cheaper and cheaper. And for us in China, a lot of dams right now, for some small dams have used this kind of monitoring method. And then I want to discuss a little bit on the new generation of data collection system. This just now we use fibers, use cables to realize the data analysis system. But traditional, this I show you, we can use 2G NIT or GPRS or 4G NIT or by cables. But right now we have 5G. Recent years, maybe we have 6G, and we have realized this technology. This can help us to have a much effective way to realize the data analysis system. So this slide show you what the new generation of data collection system mean. That means we can have a cloud, and we can use the 4G or 5G internet, and also we have wireless NIT to realize the sensors data collection, and this is very important for large dams. And the scale of the dam site normally very large, so this data analysis system is effective and also economically. So here, this I show you some components of the hardware. We have a wireless gateway, wireless terminal, and lots of sensors. So wireless terminal connect with the sensors, and the data was transformed from the terminal to the gateway, and the gateway collect all the data and then to send the data group to the center. And the data collection system, we can by computer or by cell phone apps or by professional terminals to collect the data. We have different ways. Also, it's convenient. And then I want to discuss a little bit about the new decision-making and support system. We have a lot of data, but in fact, the most important use of this data is to make the decision. So right now, for large rivers and for large dams, right now in China, we have this kind of rapid process of emergency management technology. So on the left side, left hand, we have the information monitoring, including environment, the weather report, and also real-time sensors give us a lot of data. And then we use the analysis system and the prediction models to predict the dam's data and how to do the next step, either forecast and warning. That means how to open and close the gates of the sluice gate and on the spillway, or how the flood go to the downstream, and the area may be influenced by the flood. So this is very important for the public. So right now we have used this kind of monitoring system. Also, this based on the cloud platform. This one show you the one province in Guangxi province. We use this platform and to realize the function just now mentioned. And in this system, the safety operation online auxiliary regulation system platform of more than 600 reservoir dams in this province. So you can check each dam based on one system, and it's a very efficiently way to realize the management of one province. Also, we have inspection apps, and also the reports can be automatically exported by various purpose. Another platform is the National Dam Safety Monitoring and Supervision Platform for large reservoirs. This system is right now in our center. Its function is for a comprehensive information service, safety management, surveillance, monitoring, and warning and decision supporting. And data resources, including 472 large reservoirs. And right now, more than 17 large reservoirs from central governments and 50 large reservoirs of local governments. Their information of safety management, monitoring data, and other monitoring index information, all this information are connected to this platform. So this one platform realize the function of data record, backup, transforming system, web safety, and decision-making system. It's a very large system for the leaders and for our central government to realize the dam safety management of this kind of large dams. This slide show you some pictures of this system. So we discuss a lot today on dam failure cases and dam safety management technologies. And we discuss some monitoring cases and some recent developments. So, and last, I want to make short remarks on this lecture. First, reservoirs and dams are indispensable infrastructures for social and economic growth of a country, and their safety is of significant importance. It's a background, I think. And then the safety monitoring is of irreplaceable value to control the construction quality, improve the design and understanding of the working performance of dams. So in the area of dam safety management, we know we should have proper people, proper policy, proper methods, and proper technology, and a proper construction quality. All of this safety monitoring plays a very, very important role. We can imagine it's the eye of the dam safety. It's very, very important. The dam healthy, how we know the dam healthy, we can make the decision by monitoring data and proper analysis. So this part is very important to dam safety management. Most of the decision for directors, for leaders, we based on dam safety data, not others. We should have a solid basis for some decision, especially in emergency period. And right now, development of modern monitoring technologies and their wide application provide firm foundation to enhance their reliability continuously. So for old dams and for new dams and for design period and for construction period and operation period, proper and modern monitoring technologies should be used for the dam construction. I think this another very important aspect. And right now in China, in recent 20 years or 30 years, we accumulate a lot of experience in this period. So we are very, very willing to carry out cooperation and exchanges with international partners, especially youth today. We can make different kind of cooperation by different ways. So that's all. It's my presentation. The time is limited, and I hope one day we can discuss this topic face by face in days. Okay, that's all. Thank you very much.
Thank you. Thank you, Dr. Li, for your very detailed explanation. And dear participants, ladies and gentlemen, if you have any question, please feel free to raise to Dr. Li. You may also type your question in the chat box. And for the for the decks of lectures, we will share the deck at the end of this training course. Yeah, we'll wait for like another minute to see if we more time to think and compose the question. And while you are thinking about the question, let me talk about our country report. We have over 10 countries in this training course. And routinely we will, each country will be asked to make a country report on the situation of your country respectively, and the dams or hydropower situation in your country. This time, as we have over 10 countries, we might not be able to finish all the country report within one session or within 2 hours. So if any of you have finished your country report, we may start the country report earlier. And tonight, we will have a country report from Philippines. And thank you very much for sharing with us ahead of time. And for other participants, if you have, already finished your country report, you're also very welcome to share it with us. Yeah, and I see a question in the chat box. And can we directly measure sedimentation rate of dam by using instruments? If yes, what type of instrument should we use? Yeah, Dr. Lee, that's a question.
Okay. As we talk about sedimentation, we have different type of this kind of instruments. We can directly measure the sediment by LiDAR, by this kind of LiDAR, like we use for shipping area, for the ocean shipping area, we detect fish. This based on the same method. So we can plant this kind of LiDAR on the upstream of the dam, and then we can directly detect the sedimentation. In fact, it's the LiDAR to measure the level of the toppage of the level of the sedimentation, right? So it's not a very difficult way to realize this. Okay. Okay, you're welcome.
Yeah, do we have any more questions? And you're all very welcome to share your question with us offline even after this course. So if you have any question, we'll make sure that you will get an answer. And if we don't have any question for now, this is the end of this training course. And again, we want to thank Professor Lee for his very detailed explanation. And we will see each other again about 1 hour, like at 6 p.m. China time. We'll watch 2 videos. One about the anti-drought monitoring center in Jiangsu province, and the other one is about a World Heritage site of irrigation, and then followed by a country report given by Philippines. So that's the end of this session, and then we will see you later.
See you. Okay.
Yeah. Bye. See you later.
See you.
See you.